Force, work, and energy review 13. For the graph, it has been determined that the system's total energy is 40 joules. State why the mass cannot reach x equals 1 meter. This mass cannot reach x equals 1 meter because at x equals 1 meter, you can see where I'm pointing here with my marker. At x equals 1 meter, the potential energy is about 60 joules. And if we're told that the total energy is 40, that would mean that the kinetic energy right there would have to be negative 20. And kinetic energy can never be negative. Potential energy can be negative, but kinetic energy cannot be negative. So that would not be okay. Point 2, the two boundary x values for the actual motion of the mass are the lower bound and upper bound. All right, so if the total energy is 40, that means right there, anything up here can't happen because that would mean we'd have to have a negative kinetic energy, which we can't have. So it looks to me like the lower bound is at about 1.5 meters and the upper bound is at about 5.5 meters. In which direction does the force act on the mass at the lower bound? Let's see. What was the equation? Something about the force is the negative derivative of potential energy with respect to position. In other words, the force is the negative slope. At x equals 1.5, this is a negative slope, which means the force is positive. And which way horizontally on the x-axis does a positive force point? This way. And how about at the upper bound? That's a positive slope, so that means that we have a negative force which points that way. And that means that this mass is going to be trapped within that region of space there. Let's try number 4 here. The mass is released from rest at x equals 1.5 meters. Find Vmax and the position where Vmax occurs. All right, we're going to assume that energy is conserved. So the initial energy is the initial kinetic plus the initial potential. If it's released from rest, that means the initial kinetic is 0 and it's released at 1.5 meters, which according to our graph, potential energy is 40 right there. The final energy, where is Vmax going to occur? Vmax is going to occur right down there. And we know that Vmax is going to occur there because that's where U is a minimum right there. So if U is a minimum, then K and therefore the speed have to be a maximum. So right there, U is about 10. Well, let's go K final plus U final. And U is about 10 joules there. I'm leaving the units off, but whenever we report our answer, we always put the units on there. And so the kinetic energy is going to be 1/2. What's the mass? 15, right there, times Vmax squared. Okay, so what does that come out to? So this is 40, and over here we have 10, so subtract that, so that's going to be 30 is equal to 1/2 times 15 times Vmax squared. 60 divided by 15 is 4, so Vmax is going to be 2 meters per second.